We are in right pirouette, and we now listen to Cathy Anton about injecting security controls into applications. Thank you.
Thank you very much. And thank you very much for coming to this session about injecting security controls in software applications. A few questions to better understand my audience. How many of you are security professionals working with developers? And any developers? Okay, so quite a few developers. Okay, excellent. For years, we have focused on security from attackers' point of view. We have implemented security in order for compliance regulations reasons. We develop the policies that contain the CWEs, the common weaknesses enumeration. Each company is interested to comply with. And this is how developers perceive security, like a checkbox that they must tick so their software application is accepted and then deployed in production, in particular in companies where there is a security gate for deployment in production. The result of this approach is that today we still develop a high number of insecure applications, and injection is still king. In the latest OWASP Top 10 2017, injection is still in pole position at #1. So the question is there anything else that we can do? As part of this presentation, we will look at vulnerabilities from a different angle. We will decompose this into the security controls that prevent them, are familiar to developers, and they can use them every single day while writing the code. My name is Cathy Anton, and I come from a software development background, where in my previous life I have led and created teams of developers. And this is when I got involved into an OWASP project, is the OWASP Top 10 Proactive Controls, which is a list of security controls for developers. I currently work as application security consultant at Veracode, and here, in my current day job, I work with developers around the world and help them secure their software. And during my everyday consultations, I get a lot of sad developers because their software is not compliant with the company's policy. And I get questions like, my application is behind the firewall, isn't this enough for SQL injection? Or, I have validated the input. Is this not enough to prevent the SQL injection? And my favorite, I have parameterized. Look, I'm using prepare statements. Why is this not enough to prevent injection? And this comes so often that whenever I get access to the developer's code, one of the first things I do is to actually do a search for string replace functions used in conjunction with the SQL command. So let's look. I'll start for this exploration with the injection, which is still one of the most common vulnerabilities found in software applications. The injection is a broad category. It contains multiple types of injections, and each of them have its own defensive mechanisms. And this category contains command injection, cross-site scripting, XML injection, code injection, LDAP injection, SQL injection, just to name a few injections. And this is just a selection as per classification. This classification has been done by NVD, National Vulnerability Database. And if we go further into any of these injections, let's say into SQL injection, then depending of the type of the attack and how the results are gathered, then we have in-band SQL injection, which is the most common one, where the attack and the results gathering happens on the same channel. Then we have blind SQL injection, and then we have out-of-band SQL injection, where we need a second behavior in order to exploit that vulnerability. A good example of this is the second order SQL injection, which is the injection that stays there dormant until a second behavior is in place to actually do the exploit. And this can be a cron job or any other use of database. And you don't have the same defense, the same mechanism of prevention for all of these. And I'm aware that you that came to this conference already are familiar with all of these. But the point that I'm trying to make is that there are lots of injections. And we ask this of developers. We ask them to know, to be familiar with all of these, while they actually write their own code and they focus on implementing the new functionality for the software. So no wonder that 20 years after the SQL injection was mentioned in Frag magazine, we still talk about this. And as the injection category, this has been in OWASP top 10 for the first time mentioned in 2004 when it was on position number 6. So the question is there anything else we can do? Because if we continue on the same route that we've done until now, we are at the risk of talking of injection for the next 20 years. Is there another way to look at these vulnerabilities? And to explore this, I will just start with a simple definition of what the injection is. Just the basic, I will not go into categories. So the bottom line is that the injection occurs when we have an input that is combined with sort of a syntax. The resulting string is then sent to a parser, and that is when it ends up interpreted as part of the code. So the input, which does not necessarily need to be only get or post, but can also be HTTP headers, file uploads, data from the database, configuration files, the application's configuration files. So when all this input from this wide variety of external sources is combined with a sort of a syntax that is then sent to a parser. This can be the SQL parser when you store the data into the database, or the HTML parser or browser when we actually render a web page. And this is when we end up with that input executed as part of the code. So in the case of storing data into the database, we end up with the input executed as part of the SQL command. When we want to render an HTML page, we end up with input executed as HTML code or JavaScript code, and so on. So the problem is on that output where we end up with the code, with the input executed as part of the code. So I'm going to flip this view to focus on the output. So in the case of the SQL injection, the exploit occurs when this input, which is combined with the SQL query, is then sent through the parser. And the problem is that the parser cannot differentiate between what's the input and what's the actual command. The best defense for this is to parameterize the data. Because from that point, this is the way to tell the parser this is the input and this is the actual SQL command. And from that point on, the parser will treat the input as simple strings. And this is the primary control, the best defense, because it happens at the parser level. However, we should always validate the input as a defense in depth mechanism. What this helps is that it can prevent type of vulnerabilities, type of injections that developers might not necessarily be aware of, like second-order SQL injection. In the case of cross-site scripting, the exploit occurs when input is combined with the HTML syntax and then sent through the HTML parser, the browser. The best defense for this is to contextually encode the output at the point of creating that HTML document. So just when you create it, that's the best way to defend, to contextually encode the output. But as defense in that, we should still validate the input. Similarly, for the case of XML injection, code injection and LDAP injection, we should contextually encode the output to neutralize the characters that can trigger code execution. And as defense in that, we should still validate the input. In the case of the command injection, it very much depends on which language you use. Because if the language offers the ability to parameterize the data, and this is available in Java as part of the process builder or in .NET as process, so this is what you should use to parameterize the data. If this is not available for that programming language, then you should contextually encode that output to neutralize the characters that can trigger the command injection. And as defense in that, still validate the input to validate, to have a strict validation in place for each of the arguments that we add into that command. So instead of focusing on the vulnerabilities types, which can be quite overwhelming, and there are lots of them, we can choose instead to focus on these security controls. And we should always parameterize the queries before storing the data into the database. Contextually encode the output when we create an HTML document, and parameterize the data when invoking an operating system command, an OS command. But as defense in that, we should always validate the input in order to effectively reduce the attack surface. And the best point for validation is when data enters your application. This is the best point to validate the data. In the case of MVC frameworks, this point is in controller. So this is where you should actually validate your data at that point to be effective in reducing the attack surface. The next type of issue that I'm going to tackle is the intrusion, or better said, the lack of intrusion detection. To put it simply, if a pen tester is able to get into your system, it means that there is insufficient logging and monitoring in place. And this issue boils down to two problems. The first one is that there is, for auditable events like logging, failed logins, high-value transactions, we do not have in place enough logging for those type of events. And if there is in place some logging, then the format of the logs is not consistent enough in order to allow the ops team to centralize all these logs and automatically process them in order to identify any suspicious activity in a reasonable amount of time. So this is the two problems that are noticed: insufficient logging information, and the log format is not consistent for automatically process them. And the question is can developers do something about this issue? For this, we have the security logging, which is the security control that developers can use to log security information during the runtime operation of an application. Now, when it comes to intrusion detection, there are 6 types that are considered good attack identifiers. And these are authorization failures and authentication failures, client-side input validation bypasses, whitelist input validation failures, obvious SQL injection attacks, like for example, obvious injection, SQL injection strings, and a high rate of function use. For example, you have a high number of requests for a page in a very short period of time. I'll go a little bit more in detail for this to give you a better understanding of what I mean. So in the case of request, if the application expects post, but instead it receives get, this means that somebody has intercepted that request and has intentionally changed from post to get. And this anomaly, this type of exception should be logged. Equally, if there are additional form or URL parameters, for example, debug equal true, which is something that a pen tester would commonly do to add extra things. Again, this is a good indication that somebody has intercepted that and has added those extra form or URL parameters. And this type of anomaly exception should be logged. In the case of authentication, if the application accepts to receive via post both username and passwords, but instead receives only one of them, for example, the username because the password has been removed, again, this is another good indicator that somebody has played with that and should be logged. Or if there are received extra parameters during the authentication, a good example is admin equal true, then that's another example that should be logged. In the case of input exceptions, if the validation on the server side fails, despite the fact that there is a client-side validation, then that event should be logged. A good example for this is if we have a web form. The web form has an attribute for one of those fields, the attribute of maximum length, but the string that reaches the server side has the value, the length greater than the attribute defined on the client side. So this is a good indicator that somebody has intercepted that communication since it has left the client, manipulated that string, and that should be logged. Or another example is for non-user editable fields, like for example, radio button, checkboxes, hidden fields. A good example is on an e-commerce application, on the shopping page, on the shopping basket page. If you have a hidden field of price, then that can be very tempting for anyone that does a view source on that page to play with the value of that price. And if the value of that the application receives on the server side is different from the one that is expecting the software, that's another event that we should log. So these are just a few examples of intrusion detection points. You can have further look for more of this type of points on the OWASP App Sensor page, the App Sensor intrusion detection points. But by having this validation in place, what we are actually doing from a software development point of view, we just ensure that the software receives the data it expects in the format it expects. And when this does not happen, by logging these exceptions, what we are actually doing, we're putting into the software, we give the software the mechanisms to respond in real time to possible identified attacks, these attacks that we have identified. And it can reduce the impact of these attacks or even stop them, depending on how we choose to do the implementation. So it's a good way to put into the software this mechanism of responding in real time to these possible identified attacks. Another type of issue that I'm going to tackle are the vulnerable components, or using software with vulnerable components. And this is a growing problem. I mean, this just grows more and more. And a common practice of today's software is that developers will bring in libraries from various sources and then put put them together. And bringing in library is actually a good practice because you don't want to do from the scratch your cryptographic library. You wouldn't want to do that one. So you use, in particular, using libraries with security embedded in, it's a good practice. The problem comes when these libraries are not incorporated and they're not managed appropriately. And I spend a lot of time with developers to help them upgrade their components, which this is what it ends up being. And the type of software that has this problem is the type of software that is difficult to understand. It's the type of software that no developer wants to touch because they are afraid to break it. It's easy to break. It's that type of software when you do one change here, something else breaks in a completely different part of the application that nobody was aware of. As a result, it's difficult to test. There might be few manual tests, but there's not enough coverage. And all of this problem means that it's difficult to upgrade and ultimately leads to an increase in the technical debt. And this is where we see the problems with this software, which has a high number of vulnerable components. They usually have a high level of technical debt. And the question is, can we do something about these components? And as developers, we can actually do at the point when we decide to bring them into the software. And here I'm going to go into something that developers are familiar, which is the software design patterns, but not so familiar to the security consultants. And I think we as security consultants owe the developers to learn their language and what they are familiar with. And for my examples, I'm going to consider three types of components. One of them is the an open source component, like a logging library. And this is very common in software applications, bringing in a logging library and implementing it. Another one is a vendor API. And this is another growing trend. Rather than breaching directly a company, a hacker will choose to breach a partner and then have access to the target company. So I'm going to consider that one as well, a vendor API. And the third example is of a library that is developed by another team within the same company. And this is a common practice in large companies. You have one team that develops a package that may be quite complex, and then this is reused on multiple applications within that company. So I will start with the first example, which is implementing a logging library. And like any ready-made library, usually it has a wealth of information. And in most of the cases, our application, the software, does not need all that information, all that functionality. So, for example, in this one, it might have lots of logging levels, but for our software, for the requirements of our own software, we are only interested in three: the debug, warn, and info. For this scenario, when we want to expose into our own software only a set of the functionality, a good design pattern is a simple wrapper. And what this helps, it helps to expose into your software only the functionality that you need and hides unwanted behavior. In this way, we also reduce the attack surface. If there is a vulnerability into one of the functionality that is not exposed, then that's not exposed into our own software. If the vulnerability is in something that is exposed into our own software, then we have the wrapper, the one place where we can apply extra security control if we need, but also this design pattern helps to easily upgrade or even replace a library without much penalty. And ultimately, it's about the ability to quickly upgrade these components to reduce the technical debt. The next example is a vendor API. And in the case of e-commerce applications, an e-commerce website will highly likely have more than one payment gateway, these vendor APIs. And you also need to be able to switch on or interchange these payment gateways. And highly likely that each vendor will have exposed its own methods into that API, and your own software will need its own methods. It will have its own functions. For this scenario where you actually need to convert from the provided interface to the required interface, a good design pattern is the adapter design pattern, because it helps to convert from the vendor API interface to what your software requires. And also you can have multiple adaptees working with the same adapter interface. And the last example that I'm going to look into is the scenario where you have one library that is developed by another team within the company, and then this is reused on multiple applications. A good example for this is the single sign-on, which is, it can get quite complex when actually written down in functionality. So for this, we still have to treat it like an external component to our own software. I know that it might be developed by the mate next desk that we go to pub every Friday, but it's still, for the software, it's still an external component, and we should still treat it in this way. So for this scenario, when we might need to bring into the software a complex subsystem, a good design pattern is the facade, because this helps to simplify the interaction between your own software and a complex subsystem. It can also be used for legacy applications for poorly written APIs. And if you have a problem, then you have that facade, the one place where you need to add extra security control, and it reduces the dependencies on the external code. So if we are to recap, when bringing in these components, the security starts from the design, from the point where we decide on how we are going to implement this, which software design we are going to use. From that point, the security of the software starts. And we can use a simple wrapper if we want to expose into the software a subset of the functionality provided, or if we need to convert from the provided interface to the required interface, we can use the adapter design pattern. But if we have, if we bring in a complex subsystem, then a facade design pattern is a good one to use for this type of scenarios. Another question is, okay, we have discussed by now about the security controls for injection. What should we do about intrusion detection? What about vulnerable components? But another question is, how often should we use this? To give the answer to this question, I'm going to refer to a real case. Rick Riscola was a US Army officer of British origin born in Cornwall. After the Army, he decided to move into the corporate world, and he worked as Director of Security at World Trade Center. From the moment he moved into the building, he was aware that the building posed unusual security risks, partly because of its sheer size, its symbolism, the best known building in the world. And he wanted to have a better understanding of the security risks this type of building would pose. And together with one of his ex-army friends, he actually walked around the building to see to understand the security. And once they got to the basement, they saw that the doors were wide open, there was no security. The cars were coming in as they please, the trucks. And they saw that as a vulnerability, a weakness into the overall security of the building. He filed a report to the management. Evidently, he was ignored. On February 26, 1993, terrorists detonated a bomb truck in the basement of World Trade Center. After the attack, he warned again. He said, they cannot come to the basement because now there are huge doors and they are closed. The next time will be by air. Because the first time he was right, the management started to believe him. He wanted to move the offices from World Trade Center in another location. But the lease would end in 2006, so they agreed that they will stay there until the lease ends. In the meantime, they will implement whatever he recommends. And for him, it was not a matter of if there is an attack, but when there is an attack, he wanted his people to safely exit the building. And for this, he implemented regular emergency evacuation drills. And he wanted everyone to be involved, so including senior managers. And of course, there were complaints, especially from senior executives, because they wanted to put the phone down, regardless if they were in the middle of an important transaction or not. But he managed to change the culture in Morgan Stanley and have everyone involved into these regular emergency drills every 3 months. On the day of the 9/11 attack, all but 6 of the Morgan Stanley's employees have safely exited the building. The casualties were security officers and Rick Riscola. But Rick's well-rehearsed and consistently practiced evacuation plans have saved the lives of 2,687 people. And back to our controls. Today's software is not just a simple website. There can be complex financial applications, software that can design for medical devices where people's lives are at risk. So how often should we actually implement these security controls? We should regularly implement these, and we should regularly verify that they have been implemented. So every time we bring in input into our software from a wide variety of sources, including data from the database, we should validate the input at the entry point in the database. If there are exceptions on this validation, we should log them, but perform output encoding to avoid log injection. For any output, we should contextually encode it, and every time we store the data into the database, we should parameterize the queries after the input validation in order to have that defense at SQL parser level. If we need to access a command, an OS command, then we should parameterize the data to separate the input from the actual command. And every time we bring in another library, another component, we should encapsulate it. To reduce the attack surface, we should use a software design pattern that help us to reduce the attack surface and enable us to easily upgrade these components or even replace them if needs be. Are these the only controls? Definitely not. We can add to it. For example, another one that can be easily added is that any communication should be done on a secure channel, TLS. And when I say any communication, that involves also components behind the firewall, like, for example, for non-browser components, like for a database server. This is something that is not quite there we should see more of this communication on secure channel behind the firewall, because it's not that difficult for attackers to get within a network. And this approach can be used as well to grow and add to, depending of what other many CWEs you want to comply with. So in the case that your application stores sensitive data, you can add as well to secure your data, store it, encrypt it using a strong cryptographic algorithm. But also it's important to store the keys in a secure key management solution. We still see, unfortunately, this is not quite there yet. And I'm not talking necessarily about plain text passwords, which are quite there. But what I'm talking as well about those implementations where the developer truly believes that it has been secure, but is not. So there is still work on this one. And if your company wants to add extra CWEs to the policy, like for example, they want to comply with the latest that has been added to the OWASP top 10, the CWE 611 XXC, or XML external entity. Well, the security control for that is about hardening the XML parser. So we can add this control to harden the XML parser before actually using that XML into our own software. What I would like you to take is that rather than focusing on the CWEs, on the type of vulnerabilities, which there are lots of them, and can be a little bit overwhelming for developers that need to focus on actually writing the functionality. Instead, we can choose to focus on the security controls that prevent these CWEs. And it's also important to verify that these controls have been implemented correctly, and they actually correctly prevent the CWEs that we are interested in. Thank you very much. Any questions?
We have some time for questions. Question to the audience. I find the adaptation when you bring in external software quite a good point. Honestly, any of the developers doing that regularly? Because I've seen much code where this wasn't the case, so this is really good advice. Any further questions concerning these? Then thank you.
Thanks.
Thanks again.